Hi there. Today I want to talk to you about a new productivity tool for researchers who are working on concurrent data structures, or maybe it could be useful to some other people as well, for first trying to prototype graphs to explore different ways of visualizing data to see, what kinds of graphs might be useful to show in a paper if you've got a bunch of data and you're not sure what the right way to visualize it is, and also to sort of take a lot of the drudgery out of mechanically producing a bunch of graphs over a bunch of different parameters, once you have an idea what you want your graphs to look like. So I've got a really simple Excel spreadsheet with macros that'll help you do this. It's called the Chart Factory here. I'll open it up. You've got an instructions page as the first sheet. And here I have a CSV file that was generated by some real experiments that I ran. This is quite a large CSV file. There are lots and lots of columns. This is like not a toy example. This is really, real world strength data. So how do I use this spreadsheet? Well, you can follow these instructions, but I'll just walk you through them very quickly here. So the first thing you do is you're going to load a CSV file. So you click that button and you navigate to where your CSV file is. Let me do that quickly here. So I'm going to load this CSV file. It's done. If I go over to the Data tab, I can see that this CSV file has been loaded. So lots of different columns here, all sorts of interesting information. This is for a data structure micro benchmark where we have a few different data structures here. And it's an just basic kind of synthetic micro benchmark that you see in the literature a lot, where you do a bunch of random operations on uniform random keys. In this case, the operations are all searches, and we throw up to 144 threads at this problem on a big server. And we record all sorts of interesting things, like how many operations were completed, all sorts of stats about the trees, and over here on the right we've got like information about how many cache misses occurred per operation, like L1, L2, L3 cache misses, how many cycles were performed per operation, how many instructions were performed, and so on. So lots of good data. How do we take this data and transform it into graphs so that we can, show reasonable things in a paper? So here in this third sheet, which is called Pivot, we have a pivot table. And I want to give you a little bit of a tutorial on pivot tables. They're a really cool tool for taking high-dimensional data and filtering down and aggregating data across a couple of those dimensions and displaying it in a really elegant way. So suppose I want to show my different data structures as columns and the thread counts as rows, and I want to have one of these graphs for each data structure size, where a data structure in this experiment contains about half of a fixed key range. And then I want my data to be the average throughput over a bunch of different trials. So I just kind of click and drag the fields I'm interested in into these pivot table slots, and I end up already with something that is starting to look like a graph. I mean, I have to do some things to not make it look so ugly. So here I can do things like, here's my data table produced by the pivot table really quickly with a few clicks. I've managed to create a table where the rows are the various thread counts, numbers of concurrent threads, the columns are the different data structures that are being experimented on, and the data is the average throughput over a bunch of different trials. And then up here I have this so-called filter field where I have the max key, which basically defines the size of the data structure, and I can filter my results to a certain data structure size. So with a max key of 20 million here, for example, the data structure contains about 10 million keys. So I can filter to that data, and these are results here for the case where the data structure is of size 10 million. And I can switch this filter to 200 million. Now the data structure size is 100 million. And these data structure names are rather long, so I can do nice things like rename them. So brown ext ab tree lf, I can just rename ab tree. Brown ext ist lf, I'll just rename ist. And this last one, the Natarajan bst, I'll rename bst. And I can shuffle these around. If I want bst to be first, I can click and drag this earlier. And if I want, let's see, that's an order I like. The data looks nice. I can give it a y-axis and x-axis titles. You'll notice as I update this pivot table, this chart is being dynamically updated. So we'll give it a y-axis title, which is operations per, let's make it microsecond, and I'll change the y-axis scale to reflect that. On the x-axis, let's make it number of threads, number of concurrent threads. So let's switch this x-axis. I double-click on this, and on the right, I have a chance to change details of the axis. Let's set the display units to millions, and I don't want to see the word millions on the chart, so I'll uncheck that. And there you go. Now I have actually a pretty reasonable-looking graph. So how do I go from somewhat reasonable-looking graph to nice PNG files that I can import into a paper? Well, I actually have some Visual Basic macros that I can run to do that, and here are buttons which help you tap into that without actually opening up the Visual Basic editor and running macros yourself. So what does this next graph button do? Well, it helps me cycle through the various key ranges. I click on it and it cycles through the key ranges where really it's changing this field B1 up here. It's selecting the different values of this filter field. So I chose this filter when I configured this pivot table. And up here, I have B1 written down as the pivot filter cell. My Visual Basic scripts are using the contents of this field AA2. It's seeing, oh, okay, well, I should look at field B1 to figure out what I'm filtering, to figure out which options to iterate through to produce different graph views. And next graph helps you just cycle through those different options. So if I had something more complicated than just, cycling through the sizes of the data structure, if I wanted to have like a bunch of different experiments that I cycle through to produce a graph for each experiment, then I could create, a combined field that sort of, when I pull down this box, I'm going to see all the different experiments that I'm going to run that I want to show graphs for. And the next graph button will help you cycle through all those experiments. So it's easy enough to construct a field like that in data by, just concatenating the names of a bunch of different fields, for example, or the contents of a bunch of different fields, and making a new column in Excel and including that in the pivot table. So in this case, I have something really simple. I just want to iterate over these data structure sizes, and I want to produce a graph for each. So I have an export graph button, which will take this image right here and actually export it. The way it's doing that, by the way, is here in these two fields, I have two cell names, F5 and L25. If I look at what those are, here's F, here's F5, and L25 is down here on the bottom right corner of this graph. So F5 to L25 is actually exactly the dimensions of this graph. What my script is doing when you click Export Graph is it's taking a little screenshot of that range, F5 to L25, and storing that as a PNG file in the current directory, where the name is basically a concatenation of the name of this Excel worksheet, workbook, the worksheet, pivot, and the pivot filter field name, max key, and the value, 2 million. So what does this look like? If I go look in my folder here where chartfactory.xlsm is, I can see it produced this image when I click that button, Chart Factory Pivot Max Key 2 million. And I can do this for each possible choice of max key by just clicking Export All. And if I look here in this folder, there, I can see the 4 PNGs that it produced. So great, I have something that'll produce really quickly nice charts. I can format these charts, of course, however I like, and then the export will export my nicely formatted charts. So you can edit this to a format that you like for your paper, and it's very easy to export. What if I want to show, more than one type of chart in my paper, but I want to generate, a bunch of different graphs of different types? I can actually duplicate this spreadsheet, this pivot sheet, make a copy of it. I can call it something else. So this was first pivot sheet was looking at throughput. Throughput, operations per microsecond versus number of threads. What if I want to look at some very different data? Remember, I had cache miss information in my data. What if I want to look at, say, L3 cache misses per operation plotted against data structure size? And we'll have one of those graphs for each thread count. So we'll sort of, look at the question just out of curiosity. Do the number of cache misses vary based on the per operation, vary based on the data structure size, or based on the number of threads? And we can answer that question really easily. So let's call this sheet pivot cache misses. If this spreadsheet name starts with pivot, then that turns out to have some nice properties for this workbook. If you save this workbook and you go back to the instructions tab and you load a new CSV file, it'll automatically update the data contained in every worksheet that starts with pivot. So here I've duplicated this, and let's just reshape this pivot table so it contains the information I want. So let's get rid of filters, columns, rows, and values. We'll get rid of everything. So this is an empty pivot table, and we want to look at the various data structures in columns. I want to plot this against the data structure size now, instead of plotting it against the number of threads. And I want to look not at throughput, but the number of L3 cache misses. So let's look at the average number of L3 cache misses per operation. And then my filter field is going to be the number of threads. So I'm going to filter over the number of threads. So for example, let's look at 144 threads. Here is, this of course, this x-axis label is wrong. Let's fix it. So this is size of data structure. And this is not operations per microsecond, but L3 misses per operation. That means our scale here, millions, is not very good. Let's change that. So double click on this, and we'll change those display units from millions to none. So this is L3 misses per operation, and this is plotted against size of the data structure. And this is actually maximum key in the key range. So the size is half of this. So let's correct these labels. I can just go here and write the size is 1 million, 10 million, 100 million, and 1 billion. There you go. I've rewritten my labels. And now again, I have a reasonable looking graph to print out. So I can see at 144 threads, these are what the results look like. I can filter this to a single thread and see if those results look different. I can iterate over the different thread counts by clicking Next Graph. And if I want to, at the end, I can export all of them by clicking Export All. And what does this look like? So here we now have Chart Factory Pivot Cache Misses. The name of the sheet, Pivot Cache Misses, is here in the file name. Then we have total threads 1, 18, 36, 72, 108, 144. So it's taking the field you're filtering on, the value, and it's appending those to the file name. And here we have all of these graphs, and if they happen to show us interesting things that we want to put in a paper, you have these nice PNGs that you can include. So this makes it really cheap to prototype different views of data, see what looks like it could be interesting to put into a data structure, paper, and then really quickly dump all of those to PNG files so that you can include them with include graphics and PDF LaTeX and get really easily get nice graphs into your papers. So that's it. Hope you enjoyed, and I'll see you next time.